Incredible. Okay. If you haven't already, please do the little straw poll. Be a little very helpful in engaging the talk. I think 40 votes. Are there even 40 people in here? Okay, sick. Oh, is that 40 votes overall? No, that's overall. Okay, I understand. Okay. I'm gonna stand. I'm gonna stand. All right, hold on. Let me just get this all going. Okay. Hello, my name is Weston Bell-Geddes, and today I'll be presenting to you a Unity overview to end them all. Use he, him pronouns. So my main mission for this talk is to prepare you for the Newbies and Vets Game Jam, which is this Friday. However, in doing so, I'll be teaching you just kind of a great overview of Unity game development. So even if you're not participating in the game jam, you'll learn some stuff. I'm gonna give a brief overview of Unity, talk about the inner workings of components, and just how to go about hooking up everything. We'll write some scripts, but I'm mainly focusing on the relationship between your game and the scripts rather than the scripting itself, because it's hard for me to teach that kind of stuff in this format, I feel. So, but overall, you will hopefully walk away knowing stuff you didn't know before. Really quickly, I'll talk about my credentials. Like I said, my name is Weston. I'm a sophomore studying interactive media and game design at the School of Cinematic Arts. I worked as a Unity engineer at NASA over the summer, where I program features for their VR and AR stuff. So I've been so many hackathons and game jams. I want to kind of tell you some tips and tricks that I've learned over the years. I did a couple of MIT, which I got awards for, so I can talk about that experience as well. And I don't like anime. It's just not for me. I'll be honest. No shame if you do. It's just not my thing. I'm sorry. Okay, so the game jams. Game jams are a wonderful, magical place for people who are extremely passionate about what they do, get together to create something incredible. So in the Newbies and Vets Game Jam, amateur game developers and veteran game developers are paired together to create something in 2 days. So you'll work together with a team, and then you'll get a theme, and 2 days later you'll have a funny little game. I've done a lot of online game jams as well, which are equally as rewarding, and there are prizes, gift cards, but it's not about that. No, it totally is. Okay. So why Unity? Why Unity? That's the big question we always ask ourselves. Unity is better for fast prototyping. I say this because I've done, like I said, countless game jams, and I've always almost used Unity. So that's the major thing. Other than that, it's superior for 2D, which is often what you'll be creating in a game jam. And it's also great at 3D. And I find it's easier to get the aesthetic you're always going for in Unity as opposed to Unreal. I'm actually, I'd say, more proficient in Unreal than I am in Unity. I just like it better, but there you go. All right. So game jam, what should you expect? Yeah, they're gonna announce the theme. Then you're gonna assemble a team, or if you don't have a team already, then you're going to make the game. This part will be the longest, of course. Then you're gonna build the game. I put build the game in its separate step because the worst feeling in the world is finishing a game, but it doesn't build. You get some random console error, and and then you don't get it turned in on time. That won't happen, but it might. So be careful. Then you're gonna debug it. Make sure there's no big bugs. This is also the point where little bugs become fun little features, and then you're going to submit. And that's the part where you celebrate or silently weep while someone judges your creation. So the first step, after you get your team all together, you're going to design a gameplay experience that evokes the theme. And you're going to break it down into its most basic elements, right? So when you segment a game, right? So if say you're making Mario, right? Someone has to make all the art for it, and someone has to program it, someone has to do music, et cetera, et cetera. So you're going to segment that all diverse, relay the tasks out to your team, evenly delegate tasks, and then just see who wants to do what and who can do what, et cetera. And yes, so okay, this is the fun part where we get to open Unity. I'll sit down. Okay. So if you have Unity installed, please open that now. If you don't, try to follow along now or watch the recording later because Unity takes a while to download. I'll be using Unity 2019.4.12 F1. That's the newest LTS. And anything that goes wrong is completely on purpose, just so you know. So I don't know the best way to do this. So hopefully you can see this. I'm gonna close this presentation for now, and I'll open up Unity here. You can see that. You can see that there. Yeah, maybe. Hopefully. Okay. So let's see. All right. We have baby coders. You enjoy anime. Okay. You've opened Unity, but just a little. Okay, that's good. If you made a lot in Unity, I'll make some jokes, but I don't think this talk is necessarily for you. But you're welcome to stay here. And we have 1 Megamind coder. Wow. Okay. Wonderful. Wonderful. All right. So let's open Unity. Really quick, I'll show you what I want to make. And then I'm going to explain literally everything I do. So, we're launching Unity, but it's on the other. So yeah, go ahead and launch a fresh Unity project, or just open Unity Hub. I'll just show you really quick what we're going to create. Okay. So this is what we're going to be creating today. It's a little level. It's a little 2D platformer, kind of spooky for Halloween. You're going to be able to jump all around. We're going to have a smooth following camera. We're going to have colliders. We're going to have this sort of stuff, and it's going to be a fun little time. We're going to make a little level, just like that. Okay. So now we're going to close this, and we're going to open. We're going to make a Unity project together as a family. So excited. Okay. So here's Unity Hub. What the first thing you're going to do? We're going to press new. This will create a new project with the newest version of Unity you have installed, and we're going to select 3D since we're making a 2.5D platformer, which basically means that since it kind of looks 2D, but it is actually 3D assets. So make a 3D game, call it whatever you want to name your game. We'll call it Mega Game Jam. I'm not participating in the Game Jam, so that's okay for me to call it that. But if you are, maybe that'll be confusing for this Friday. And then we will press create. Now it's going to load. I'm also going to scream into my pillow right now. Oh, that's for later when Unity doesn't work for no reason whatsoever. So this is a preemptive screen. I always do that. No, I don't. All right, so now we're launching Unity. It takes a little bit, but you know, it's got a lot going on. Okay, here it is. Oh my God. Wow, isn't that beautiful? Fresh Unity project. Okay, so this is Unity. Welcome. If you haven't opened Unity ever before, this is Unity. I'll go ahead and explain. So on the left here, we have the hierarchy, which is going to be a list of all the objects in your scene. This big section in the middle is called your scene view, which is a visualization of the 3D game world. It also allows you to manipulate and interact with objects in 3D space. I'll go over that in depth in just a second. The right side here is your inspector, which lists all the details for a selected object and all the components attached to it. And the bottom tab here is your project view, which lists all the files and folders in your project. Okay, so as you can see in your project view, you already have a folder called scenes. So this is the first thing we're going to do is make other folders. So you're going to right click and you press create and you press folder. We're going to do this because it really helps to create folders so you're really well organized when you create other assets. So we'll make a folder, we'll call it scripts. Scripts holds all of your Unity C# scripts that you will be programming. So real quick, I'll go over how to navigate around the scene. So this is your scene view right here, right? So if you go ahead and you right click in the scene view and you wiggle your mouse around, you can see how you look around the screen. If you played any game ever, you probably know about WASD, which is how you navigate around the scene here. So go ahead and try that now. If you press W and S to go forward and back, and A and D to go left and right. There's some other useful commands like Alt left click and Alt right click. But for now, just use WASD. Alt right click does a zoom thing, and Alt left click does a rotate based movement. So rotation-based movement. Okay. So now we are going to make our first object in our scene. So we have this render, but not, right now there's nothing rendering. If we switch to the game tab here, it shows us what the camera is rendering in the scene. And right now that is nothing because there's literally nothing in the scene, right? We have a light source, which if we delete, it makes it all dark. We have a camera. So we're going to go ahead and right click in our hierarchy and we're going to press 3D object, cube. Boom! Do you see that? A cube appeared. Okay. So now if we go to our, if we look inside the scene, we can see that a cube has appeared. And if we move that to in front of our camera, we go to game view, a cube is now being rendered in our game view. But that is awesome. So go ahead and make that cube. So what are we making? We're making a 2D, no, we're making a 2.5D platformer, right? Little guy who jumps around and stuff. So what do we need? We need a ground and we need a little player who can jump around, and then we'll go from there. So we'll start with the ground. So an organization thing. I like to right click my the cube I just made and press rename. I'm going to rename it to ground. This is not necessary, but it's really useful in organizing your scene. So now we're going to go ahead and we're going to scale it. So we see this transform here, right? And in this transform, we have a position, a rotation, and a scale. The XYZ fields represent the position of the game object in the world. So as you can see, you'll see these little arrows when you click on a game object. And as you move it up, you see this Y value goes up. And as you move to the right, this X value goes up, right? And same way, -0, 0. So to recenter any object, you're going to right click on transform, press reset. That's very useful. So as you can see, we move in 2 dimensions at a time. We either move on X and Y, or we move on this XZ or YZ, etc., etc. So that is how you move as position. Rotation, very similar. You're going to press E. You're going to press E to rotate an object. It's very, very similar. It's Y to rotate like this, Z rotate like this, just like that. We're not doing a lot of rotating for a platformer, but that's good to know. And scaling is very similar. You're going to press R, and you can click and drag to scale something up like that. You're gonna click the cube in the middle here to scale it uniformly on all axes, or you'll click on just X axes or Y axes or Z axes. They may have noticed this is starting to look like a floor if we do that, right? Now we are creating a 2D platformer or 2.5D platformer, like I said. So we're going to be extending it on its X axis, just like this. So we'll do that, and then we'll extend it on its Y axis, just like that. You can also type in 20 and 10, like over here in the transform, to get more accuracy, but generally freehanding it is good enough. Great, and then let's move it down to 5, so it's all nice and pretty. Awesome. Okay, so now what are we doing? Well, we have a ground. That is incredible. Now we have to make a player, right? So let's go ahead and add a player capsule. So once again, we're going to right click in our hierarchical view, and we're going to say 3D object capsule. Excuse me. This capsule is a little tiny guy who is going to be our player. You can make this a cube if you'd like. You can make this anything you want. Like I like to make it a little capsule. So the first thing we're going to do is we're going to add a character controller to the capsule. So if we go to our inspector, you see this add component value right down here. And if you type in, and this is every component in Unity. You can import more, etc. But for now, this is all you're going to need. If you type in character controller and click, it's going to add a character controller component. Real quick, I'll go over what else is here. So when you add a capsule to a scene, it has a capsule mesh, which is the capsule's 3D model. It has a mesh renderer, which renders the mesh in 3D space. So if we turn off the mesh renderer, you can see that it disappears. However, the capsule collision is still there. This is useful if you want to have an invisible wall or something like that. And you see we have all these different sort of things here. We have materials. We'll be adding materials later. We have lighting. We can see if it receives shadows or not. We have some more complex lighting options here. We have a capsule collider, which is useful if you want something to not have a collision. And you toggle this on and off using this little toggle boolean to the right here.
Weston,
Yes.
people are asking if you could go slightly slower because I think people are having trouble catching up.
Okay, I appreciate it. I
Yeah.
keep chatting. So thank you.
Don't worry, we're recording this and we're going to send out the recording by tomorrow. So if it's difficult for you to either follow or like jump between Zoom and Unity, don't worry about it. We'll have that as soon as possible.
I will go slower. I'm very sorry. I know how annoying that can be. I will delete my capsule. Okay, so we have the ground, right? So I'll just redo the capsule part. Hopefully you're all here. So we have the ground. We're going to right click 3D object and create a capsule. Here's our capsule in 3D space. I'm going to right click transform and reset it so that it's right next to us. Once again, that's right clicking transform and resetting it so the position is 0, 0, 0. You can also type any position you like, but you can also right click and press reset. Great. Okay. So go ahead and move your player capsule up just above the ground here, which is about at 1. I'll put it at 1. I'll put it at 2. No, I'll put it at 1.5. So we give them a little time to fall. All right, so hopefully you have your capsule there. Now we're going to add a component. The component we're going to add is called the character controller. This is Unity's built-in thing to help you create a character controller pretty easily as opposed to writing all your own stuff. It's totally very, very useful. The last thing we're going to add, the last thing we're going to do to the player is we're going to rename him. So we have a ground game object. And now we're going to create a player game object. So we're going to right click, rename to player. Awesome. So now we have a ground and a player. That is, I think that's pretty good. So now we're going to go ahead and do some scripting. Great. So let's go ahead and go to our scripts folder. Once again, to create a folder, it's right click, create folder. So scripts. So our scenes folder has our scene in it that we're working in right now. And our scripts folder has nothing because we created that. So we're going to right click, press create, C# script. Once again, let's right click, create, C# script. Now we're going to name the script what we're going to create. Let's make it the player controller. So I will call it player. I'm going to give you a little tip right now. If you accidentally name a script something, I will do it just to show you. Because this happens a lot as an accident. This is Visual Studios. If you don't have this installed, please do that. It makes coding in Unity so much easier. If you right click, create a C# script, and let's say you mean to name it player, but you call it Blair with a B, and you're like, oh, I didn't mean to do that. And now you go and you're like, well, logically, I can right click and rename. Don't do this. You don't have to do this unless you really want to. I'm just showing you. And you call it like player script. And you think it's all good, but it's not. Because if you open the player script, you can see that the public class is still named Blair, which is what we did not want to call it. And this messes up Unity so much. It's really mad at you. So go ahead and just delete it and start again. So I will do that. Okay, here is player.cs. This is your player script code. So Unity always starts it with a void update and void start. And these two comments here that are in green, which have been noted with these 2 forward slashes. So void start starts the first frame of Unity. So the second your scene begins, void start is called and things happen that you put inside these 2 parentheses here. In void update, it is called once per frame. So that's every single time a frame is rendered, which means like every single millisecond of the game, something is going to happen. You don't want to put a lot in void update because then your game will be slow because it has to do those computations every millisecond, right? Great. Okay.
So let's go ahead and start coding. I'm going to delete void start because our player doesn't need to do anything in void start. So you're going to select it and delete it. So the first thing we're going to do is we're going to define our variables. So at this point, you're just going to have to kind of trust me a little. I'll explain the best I can, but there's just some stuff that you need to have a more complex understanding of programming. So we're going to create a public variable, which means that everybody can see it in Unity. All the scripts can see it in Unity, and you're able to edit the serialized fields inside of Unity's components. So we say public, and we'll say character controller, controller. So here what we're saying is we're doing a public variable of type character controller, and we're naming it controller. So this type here is very important. We're going to be accessing the character controller that we added to the capsule component. If you remember, which I'll show you, it is this thing right here, this little character controller. So that is our first thing. The second thing we're going to do is, well, what does a player need? A player has speed, right? A player has to be able to move. So we will do a public float speed equals 1f. So public, once again, that is a public variable, meaning that anybody can access it. The float is think of it as a number that Unity has to store. And speed is, once again, what we call it. And we're going to set a default value to this, which is why we say equals 1f as opposed to just having nothing. And I want to say it's equal to 1f. And this f is used to denote that it is a float value, which Unity prefers to anything else. Awesome. So since we're going to just be working on the x-axis right now, we're also going to have a float called x velocity. So we're going to have a private float x velocity. Awesome. Okay, so private, we want this very private. We don't want other people messing with it. So we call it a private float, which means that other scripts cannot access it. It is only internal to the script. And float, once again, is referring to the type, which is a number, and x velocity. Okay, I hope everyone is following. So the first thing we're going to do is we're going to get input from the player controller. So in our void update, we're going to say float, and we're going to make a new variable. We'll call it x input, because this is the x-axis input, is equal to input.get axes raw. I'll go over that again. Float x input is the name, and that is, we're going to set that equal to input, which you type, and then we're going to do a dot, which will allow us to access variables inside the input class. An input class is something that Unity gives us because they're very nice. And then inside of, when you press dot, you see all these little functions you can put on top of it, right? All these gets. So what do we want to get? We want to get the axes raw. So you can either type that or you can double click it. And then if you look here, it says float input get axes raw. It is returning the value of the virtual axes identified by axis name with no smoothing filtering applied. This is very useful to see what a function takes in. So it's looking for a string of the axis name. So what axes are we working on? We're working on the horizontal axis. So I will say that horizontal. I spelled that wrong. Horizontal. Awesome. Okay. Now, the next thing we're going to do is we're going to change the player's x velocity, which you've already set. So we're going to press enter twice and make sure you're doing all this inside of a void update. So these two parentheses here, these denote the beginning and end of void update. This is the beginning, this is the end. And this last parentheses is the entire class. So you never want anything to go outside of that for now. So float x input. Now we're going to change the x velocity based on a value x input of some multitude of speed. So let's go ahead and say x velocity. So as you can see, when I typed xv, right, it's already trying to guess what I'm trying to say. So if you press tab, it will automatically fill. That's a little fun trick. So if you go ahead and you press x velocity, it will automatically fill what you're trying to type. So you can try it again. X input, right? It's already there. You can also just type it if you like typing. Times speed. So what this is doing is we're multiplying our X input float by our speed float, 1F. Since our speed float is 1F right now, we're basically just multiplying it by 1, which means nothing, right? But when we want to scale that up, it will be very useful. Awesome. So last thing we're going to do is after we do this, we do this computation in update, we want to actually move the player controller, right? So we named our character controller up here, right? So we're going to say controller dot move. This, if we look at this more complex function, taking absolute movement deltas. Don't worry about that. But so now we're going to say move, and we're going to open parentheses that, and we see it takes a vector 3 of motion. So a vector 3 is if you've taken math, is a vector that has an x, y, and z coordinate. So if we go ahead and, or component, excuse me. So if we go ahead and we say vector 3 dot, remember dot is how you kind of access another layer of a component, right? Times x velocity times time dot delta time. This is the part where you kind of trust me a little bit. So time to delta time is referring to how Unity interprets time, since there's not actually time inside of Unity, it's just counting frames. So that's how it refers to how we move things inside of Unity. So let's go ahead and save that. Okay. So let's just recap. We created 3 variables, 2 public, 2 private. I've organized it so the public variables are together and the private variable is not there. I just did that by putting an enter there. We have a void update, which has a float x input, which we set to equal input.getAxes raw horizontal. Okay. And then the x velocity is equal to x, the x velocity, which we denote here with private float x velocity, is equal to x input times speed. And we're going to controller.move vector3.right times the x velocity, which we've just computed here, times time.delta time. Great. Okay. So save that. Make sure you save it. Press Control S to save. If you do not save, Unity will pretend that there is nothing in the script and it will do nothing. So let's go back to Unity. Yes, okay. Thought it was over. Now we're going to the player. So if you've not clicked on the player right now, go ahead and click on player in your hierarchy. You can also click the player in your scene view, which is more of a visual, more visually pleasing. So you're going to add a component to player of the script that we just created called player. So if we type in player, you can see that there's a little script here called player that we just made. So click that, and it will add the player script to the player. I'm going to check chat just to see what's going on. Oh, okay. I will answer questions briefly. Okay. Okay. I'm so sorry. How can we access the slides? Yes, I will. I will share the slides. My script is not recognizing model behavior. My script is not recognizing model behavior. Not recognizing model behavior. Are you using Visual Studios? So I can't access the class functions. Okay. Yes, Unity prefers float over doubles. Yes, okay. I'm sorry, my Script is not recognizing mono behavior and character controller. I did add a character controller. Yeah, so I was just going to say something like that. Hopefully you have these using system.collection, using Unity Engine, using system.collection generic items at the top. I'll paste these in chat right now, just in case. You don't have this at the top. And make sure your class name is equal to the name of the script in Unity, because that makes Unity very angry. And this is type of model behavior. So does other editor works fine? Other editor? Oh, yes. So I prefer, are you referring to Visual Studios, which is like mono-develop or something? I prefer Visual Studios personally. Mono behavior, maybe. Mono-develop. Okay. I'm very sorry. I'm not entirely sure. Unity is very, very difficult sometimes. So, so here we have the player script, and inside of it we have components, right? We have everything that we've made public inside of the script. We have controller and speed. So in controller, if you click this little circle right here to the right, you can see that it will give a list of all the objects in the scene that have a character controller component, that is the player. So it's just, okay. So, once again, to add a script, just in case, you're going to press add component player. If you were done that, do not do it. And then you're going to have the script here, which has a speed variable and a controller. To add the controller, you can also drag in player, just literally click and drag from hierarchy and put in the player there. So now if we go ahead and we press the play button here, this is how you simulate a Unity environment. So if you press play, it will start a play session. So then if you use your A and D keys, you can move left and right. So if we increase the speed here, which we can do this live, we can see that it goes faster. It goes left and right faster. Incredible. Okay, so if we make this really big, it goes really fast. And if we make it really small, you can barely see it moving, right? To edit this, once again, you're going to make sure you're clicked on player, go to the script, and click speed, and set that variable to whatever you want it to be. So, you know, I'm playing around. I'm not exactly sure how fast I need him to move yet. So, but this looks pretty good. I feel pretty good with 5 right now. However, the second you take it out of play session, it will default back to the thing that we have set it inside of Unity, which is 1F, right? So, but just keep that number 5 in your head, maybe. Incredible. So now we're thinking, what do we want to do next? Let me look at chat. I noticed that too. I created the player script and everything came ready in default, so Spring was right. So okay, that's interesting. I'm very sorry. I'm not entirely sure. 1F is one of the standard. Float is the standard. One, like the usual. The usual is relative to the project right now. We're using 1F to denote that is. I always use 1F because that is as compared to a Unity unit, right? So the 1F is the standard, I would say. But generally, like if you were making a car that went faster, you might want to do 10F, some scalar value of multiple. Incredible. Okay. Good job. I'm very proud of all of you. So we're going to go back to player, the player script. We're going to double click. And we're going to do, well, what do you want to do now? What do we want? Well, let's see. We have a player, and he's funny, and he goes left and right. But, you know, maybe we want to make him jump. Okay, let's make him jump. So, to make the player jump. Also, quick note, let's write some comments. So, comments are how we tell people what code does. Now, they're useful for non-coders and coders alike. So what are we doing here? What is float.xInput equals input.axes get axes raw? Well, we're getting input, right? So I can make a little comment by putting 2 forward slashes and then saying get input. And then put a little smiley face, maybe. I don't know, just lightens up the code. I like to do that. NASA did not like that, though. They thought that was weird. Anyways, so we're gonna get the input. We get the input, get axes raw, horizontal, right? So this is a little comment. What do we do here? You don't need to comment every single line, but it's nice to remind yourself and others what you're doing. Also, if we're like, this doesn't work, you know, we can say we can say that, and hopefully someone else will realize, oh, this part of the code doesn't work. We can try to work that out. So we get input here. You can also put comments at the end of lines, which is also acceptable. Here we compute, I will say, x velocity, by multiplying x input dot speed. Now this line is quite straightforward, so maybe I need to comment this. And then here we actually move the player. The last way you can do a comment is forward slash, what's the little thing called? Asterisk, yes. Forward slash asterisk and saying move player and then a asterisk forward slash to end that comment. So these are 3 different kind of comments, which we have a line to itself, a line, part of the line, and after. This is not absolutely necessary. Once again, this is just to help readability for your code. Wonderful. So inside of update, we're going to do a couple more things. Well, we want the player to jump. Now we think about jumping. What is jumping? What is jumping? Okay. Jumping, what do you need to jump? You need a velocity in the y direction, right? You need an upwards velocity. You need an upward speed. You need a jump force. You need a, when you jump, right? So you got, what happens? You jump, you apply a force to the ground, and you go up, okay? So we need an upward speed, and then we need a y velocity to keep track of that speed because it's not always the same, right? At some point, it reaches 0, and you start going back down. Why do you start to go back down? Why do you slow down? Gravity. Okay, so we're going to have something called gravity as well. So go ahead and make another public float, and we'll call it jump speed. And we will set this to 5f as opposed to 1f, because we know that we want the player to be able to jump faster than they do walk, right? Because that's generally how life is. So once again, a public variable of type float named jump speed is equal to 5f. I will look at the chat now. Okay. Edit parameters external tools. Yes, thank you very much, Grace. Okay. Awesome. Public float jump speed is equal to 5f. And I'll go ahead and make a public float called gravity strength. Or we'll just call it, no, we'll call it gravity strength. And we will make this, we'll make it 10. It's 9.8 meters per second square, right? But we'll make it 10 because we like to round up, so Unity doesn't have to do so much math. And lastly, we need another private float to keep track of the velocity and the y direction, right? We're making a 2D game in a 3D game engine, basically, or a 3D game environment. So we're gonna have an x velocity and a y velocity, right? Incredible. Okay, so now we're gonna write some code. Okay, so let's go ahead and make a function. So underneath void update, this is important. So after, remember I was talking about the opening and the closing for void update? After the closing parentheses for void update, go ahead and press enter like 5 times. And then we get a nice little area here we can work with. But make sure that it's still inside of the class, meaning that there is one more parentheses here that closes the public class declaration. This is very important. So now we're going to make a function that allows the player to jump. So we're going to call it.
Excuse me?
Yes.
Sorry, real quick. Jackson noted in the chat that velocity, the y velocity is misspelled. So we just.
Thank you so much. Thank you very much. I'm sorry. A little nervous, I guess. No, I don't know. Thank you very much, Gabriella and Jackson. Yeah, I don't own AirPods, but I don't even want AirPods. Now that I think about it. Okay, thank you very much. You can misspell things. But if you misspell them twice, that's bad because like if I had called it X Velo City or whatever I called it, and I called it that again, and when I was trying to access that variable, that would be bad, or that would be good. But if I spelled it correctly in one place and misspelled it in another, that would be bad. So thank you very much. So private void jump. I'll explain what this means in just a moment. So we're making a new function. Congratulations. This is going to be a private function that returns nothing. So in computer science, a function's purpose is we give it something and it gives it something. It gives us something back. Except we don't want to do that. Sometimes we just want a function to do something, and we don't want anything in return, right? Isn't that what this is all about? Okay. So we call those kind of functions void because it returns nothing, right? It returns void. And it's called private because we're only going to be referencing this function internally, meaning we are not going to have it. We're not going to have another script call player.jump. So we're all going to do that internally. So we call it private void jump. And this is the type. This is the name, which we will call jump. Now these two open close parentheses denote that it is a function. This is very important. So I'll type it one more time. So we say private void to denote it returns nothing. If we want it to return a float, we'd type private void float, but we don't want it to. Excuse me. So private void jump. And now in these parentheses, you usually put in the inputs for jump. However, since, like I said, we have a void function, we don't want any inputs. So jump. So now we're going to say, okay, what should jump do? Jump should make the player jump, right? So we're going to say let the y velocity, that is spelled correctly, equal to jump speed, just like that. I use tab to autocomplete there because that is very useful, but I will type it again. So y velocity is equal to jump speed. And then I should have explained this. I'm very sorry. At the very end of every single line, you must put this. This might actually be your problem, Z. You must put a semicolon to denote that that is the end of a line of code. So let me know if that helps you, Z. Because I should have explained that. I apologize. Yeah, that's just very custom at the moment. So anytime you have a line of code that's not a declaration, like a void update declaration, or excuse me, that's not a function declaration, like a void update or a public class declaration. You're going to want to put a semicolon to say that is the end of the line of code, proceed to the next line. This is different depending on what programming language you're in, but generally, semicolon, we're in C# right now. Go ahead and save, press Control S to save. We're not done, but it's always a good habit to get into. Now we're going to how we have to call the function. So to call a function, we just call it the thing that we've already declared it here, which we have declared it private void jump, open parentheses, close parentheses. So we're going to say jump inside of void update. So if we go ahead, so you're going to press jump, or excuse me, you're going to type jump, open parentheses, close parentheses to denote that is a function, and then a semicolon. The semicolon is, like I said, to end the line, and since we're not declaring the function, we put the semicolon. Now, if we remember what void update does, we can kind of pretend that we're Unity and read the code. Okay, so every single millisecond, it's going to do everything here. We don't want the player to jump every single millisecond, do we? So we're going to do a wraparound of this function. We're going to use an if statement because we only want the player to jump if they press spacebar, right? So how do we do that? Well, we say if. You're going to type if and then open parentheses. An if statement is the most basic function in computer science, which checks if something is occurring or not occurring. A Boolean, yes, true, else, or excuse me, no, false, right? So if we get an input, which you're familiar with, input dot, and now we want, if you press a space bar, we want it to jump, right? So if input get key down, which is right here, get key down, right? And then what does get key down take? It returns true during the frame the user starts pressing down the key identified by the key code enum. Okay. So as we can see here, it's a Boolean input, get key down, that takes in a key code of a key. So we want it to be spacebar, right? Because spacebar is funny. So we open parentheses again, and we say key code dot space. Incredible. Make sure your parentheses are correct there, which is to say that it should be if open parentheses, input dot get key down, open parentheses, key code dot space, close parentheses, open brackets. In the open bracket, we're going to put our function called jump, and then the function called jump is going to call this private void function here, which sets the y velocity equal to the jump speed. Excellent. Now we're going to press save. And let's just see what happens. So when you press save, that saves the file to Unity. It's going to think about it for a little bit. And now if we look at player, we can see that player now has a jump speed and gravity strength variable. Awesome. So let's go ahead and play it. Now we can move side to side. And okay. We can move side to side. Jump speed. Okay. So something we haven't dealt with yet is gravity, right? So let's go ahead and do that. So we have a variable here called public float gravity strength, which we say is 10f, right? So let's go ahead and make a function that does gravity, right? So let's make a private void, which is a function that that applies gravity, right? So we're going to say, let's make it apply gravity. Incredible. Once again, a function that takes in nothing. So we put open parentheses, close parentheses, and then we say open bracket, we press enter, and now we have this beautiful little thing here. And now we want to say, okay, let's do pseudocode. So pseudocode is saying, okay, if the player is not on the ground, we want to apply gravity to player until they are grounded, right? So now that we have that, let's really quick go ahead and make a little edit to our code that we've written before. So if we go to controller.move, we need to add a little thing to this line to account for jumping that we just programmed. So we're going to say vector3 dot up times y velocity plus vector3 dot right times x velocity times time dot delta time. So now this is going to move the player plus handle jumping. So I'll go over that really quick. This is what your line should look like. It should say controller dot move vector3 dot up. So now we're dealing with both up and right and left directions. Vector3 dot up times y velocity plus vector3 dot right times x velocity times time dot delta time. I will look at chat. Can someone help me link the script? Can someone help me link the script to the player? Absolutely. Did you get that working? So the script to the player. So If you go ahead and click on your player, you're going to need to apply the script that you've written as a component to the player. So go ahead and press add component and then type in the name of the script that you've just created. So right now we've only created player script, so you're going to press player. If you've done this, do not do it again, but if you haven't done that, please do that. Great. Okay. So now if we run, we should be able to move left and right and jump. Oh, he jumps kind of a lot. So there's a little problem there. He moves quite nice, but his jump speed is a lot, and he has nothing to bring him down yet, right? So let's crush his dreams, bring him back down to reality. Let's make a function that applies gravity. Okay. So inside of apply gravity, let's go ahead and write an if statement. So you can read our pseudocode. Pseudocode is basically what you should always do before you write something, which is like you do it in your mind and you think, okay, what do we need to do? Well, if the player is not on the ground, then we should apply gravity to the player until they are grounded, right? So let's write that. If, right, the player, our player is called controller, is grounded, then we want to do something. But we want to see when the player is not on the ground, right? We only want to apply gravity when the player is not on the ground. This is not the case in real life, but we are in Magic Game Land where we have to make some exceptions because Unity is not as fast as physics in real life. So we say if controller is grounded, excuse me, we use the exclamation point to denote is not. The exclamation point is, think of it as literally a not, right? If controller is grounded is not, right? So for now, just put the exclamation point right before controller that is grounded. Incredible. Okay, now let's go and say y velocity. What do we want it to do? Okay, what do we want it to do? We want it to apply the gravitational force or gravitational speed, right? Or excuse me, gravitational strength until it is not grounded. Okay, great. So what does that mean? Well, we're going to say minus equals. Minus equals says we're going to set it equal, but we're also going to subtract. So we say y velocity is equal to minus equals gravity strength times time dot delta time. Once again, that's y velocity minus equals gravity strength. And gravity strength is the variable that we have said is 10F up here. Times time dot delta time. Awesome. So that is our applied gravity function. So the last thing we have to do is we have to call the applied gravity function, right? So when should we apply gravity? When should we apply gravity? Well, we should probably apply gravity before the player jumps, right? Because if we apply it after the player jumps, that's not going to help us very much. So if we type apply gravity inside of our void update, right? Because code is read from the top down, right? It executes from the first command to the last, and then it repeats infinitely until we stop playing. So apply gravity, and that's a function. So we open and close parentheses, then we press the semicolon. The semicolon, like I said, denotes that is the end of the line. Go to the next. Great. Excellent. So is there anything in the chat? Let's see. That feeling when the programmer crushes your dreams, it's true. It's true. But you know, code often crushes my dreams too. We just have that kind of relationship. My controller under the linked player strip on the right says none. Character controller. Okay, so you're going to go ahead and press this little circle right here next to player, and you're going to click it, and it's going to give you a list of all the things in the scene that have a character controller component. And then you're going to press player, and it'll be there. You can also click and drag from your scene hierarchy. Thank you, Z. Okay, Why do you multiply movement by time? That's an incredible question, Truman. And something that I don't think I could answer effectively in the time allotted. But just think of it as this is how you tell Unity that something is moving with respect to time, right? So if you think of physics in real life, everything is a function of time. So this is how we tell Unity that this y velocity gravity strength is a function of time. Same with controller.move time. We say everything here is a function of time and should take time to execute. Okay. So now we have a little guy who moves back and forth. He still jumps quite fast, I'll be honest. Okay, so let's make jump strength like 1, just see what happens. Okay, now he jumps kind of, he's kind of cute. I don't know, I kind of like it. Oh, but look at that. We've accidentally given him a double, triple, infinitely many jumps. So hopefully you're here. So if we go ahead and we give him like a 4 speed, we give him a 4 speed, and we'll give him a jump speed of like 0.5, and we'll give him a gravity strength of like 5. See how that feels. That feels pretty nifty. Like I said, he has kind of a couple jumps. We've almost made Flappy Bird here. That's kind of nifty. Okay, so let's go ahead and fix that because we don't want a double jump. We could. I don't want it right now. So let's go ahead and think of that. So how did we do it here? We said if the player is not grounded, then we do something. Well, what if he is grounded? If he should only be able to jump if he's grounded, right? You can't double jump in real life, which I'm not going to demonstrate unless you really want me to. So we're going to say if controller dot is grounded, just like we did on line 45 here. By the way, it's very useful, these line counts on the left side here, which tell you what line you're working on, which is on the left side of the Visual Studios here. So private void jump. If the player is grounded, then we set y velocity equal to jump speed. But if it's not, we do nothing. So generally you'd say else, right? You can have an else statement here and be like return, but you don't need to do that because programming just assumes that you don't want anything else to happen. So go ahead and save that, Control S. You can also click these floppy disks in the corner if you're more of a tactile kind of person. Double jump. It's because Unity counts frames. So when you hold down a button, you run a function. Yes, Lawrence, that is true. Incredible. Okay. Let's see what happens. All right, so now we have a little guy moves side to side. He jumps quite fast, but he cannot double jump. Let's go ahead and edit. So like I said, press on the player. We can also see this kind of cool view of our game in real time. If you click the scene button here, there are 2 tabs here. There's a scene and a game. You can switch between those. That's very useful to do. So in the scene game, we're going to press game and player script. Go ahead and change gravity strength to like 1 maybe, and jump strength to like 1, and player speed to like 5. And then you can see he moves, and he has he still jumps quite heavily. So let's put gravity strength to like 5 and see how that feels. That feels good, and he cannot double jump anymore because it's waiting for him to be grounded. So we start to see this kind of cute little, it's this cute little game. All right. Woo! That was a lot. That was a lot of code. That was a lot of coding. Okay, good job. I'm proud of it. I'm proud of all of you. Maybe we have a little musical interlude. All right. That's enough. So let's go ahead and make let's make the game more exciting now. So the first thing I'm going to do to make the game more exciting is make it not this ugly background. So if we go ahead and we click on our main camera here in our scene hierarchy, we see here we have a transform and a camera and an audio listener. So if we go to the camera here, we can click background. And background brings up this cool little 3 vector constant color palette here, which we can make any color we'd like. What about a nice seafoam green? Any seafoam green fans? Okay. So if we do that, and we changed it from skybox to solid color, you can see in our camera preview that it is now going to render a nice seafoam green background, right? Let's also go ahead and open our script really quick and change the speed to like 5, and we'll change the jump speed to like 2, and the gravity to like 6. Then you're going to save that, play around with these variables, and get the kind of motion you're looking for. So then we do that. It's still quite a lot. Let's look at player. It did not change the variables. So if we go and we click play, we can change the speed and the strength, just like that. And then we get some, we can start to get the sort of movement we're looking for inside of Unity. Great. Okay. So what's next for our game? Let's add some funny little materials, right? So I made the background green, so maybe I'm going for sort of a under the sea theme. So if we go to our assets project window here, we right click and press create. We're going to make a new folder. We're going to call it materials. Once again, that's right click, create, folder. Then double click to access the folder, and inside of it, you're going to create a material. So once again, that's to right click in your project hierarchy, or excuse me, right click in your project, press create, and then press material, which is just here under audio mixer. So we're going to make a new material. Let's call it player mat, to say that this is the material the player is going to be. So now we're going to go ahead and we're going to click the player mat, and we're going to drag it onto our player. And now if you click the player's mesh renderer, we see that in element 0, we have player mat. So we go to player mat, and now what do we want it to be? I don't know. I'm thinking maybe it was a little fish, you know, like in Finding Nemo game, right? That'd be kind of quirky. There it is. Great. So now let's go ahead and play and see what it looks like. So now we have a little cube with a seafoam green background with a nice orange tone going on. I like that a lot. Okay. So what else do we need? Well, we're making a platformer, so maybe we should have some platforms. Let's make one more mat first. So right click, create material. Let's name it ground mat. Double click it to make sure that it's selected here. And let's make the ground mat a nice, like, let's make it like a nice, like, brown, you know? There it is. Beautiful. All right. Now we apply that, and suddenly we have, that's not that beautiful, but maybe this is a bit more brighter. Okay. Incredible. Okay, perfect. So aesthetically pleasing, not so much, but you know, we're starting to get some interesting sort of platforming here, huh? Okay. Great. So what else do we need? Let's go ahead and add some platforms. So if we go to ground and we right click and we press duplicate, we will get a ground 1. And ground 1 will be placed directly on top of ground. And we're going to change it so that we're going to make a little level here. So this is where you can freestyle a bit, right? It might help to go into 2D view, which you can do by pressing 2 on your keyboard, or by clicking this little 2D icon here. So when you go into 2D view, it's easier to design levels like this. You can also hold Control to snap to a grid, which is useful as opposed to just moving willy-nilly like. That was weird. All right, so let's go ahead and give them a little stare. And if you press 3, like I said, you can resize it just like that. There you go. And then, you know, we'll give them a little ramp, maybe a little. You can also duplicate by pressing Control-C and Control-V. We'll give them a little ramp to go up or go down over here. You know, we like to have fun. And just like that. Incredible. So let's play the game. Oh, look at that. We're starting to really see something now. So let's make speed like 3, so jump strength to like 1 and gravity like 5. So that feels pretty good. So now we can jump. Oh, look, now we're up there. Isn't this lovely? So this is how we create a level environment for our scene. So we have just created a platformer game. Good job. Now, wait a minute. What if I want to go down this ramp? I can't see him. He goes away. That's so sad. So we need to make one more script, a very short script. These are my favorite. That is going to follow the player. So let's go ahead and go to our scripts folder, which currently has one very lonely script. And let's give him a friend, because everybody needs a friend, right? So we go to Create, C# script, and let's name it Camera Follow. This is a script we're going to apply to our camera that follows the player around. Now, if we want to do this really quickly, we could just take our main camera and click and drag it onto our player. Now, if we do that, we see that it works. It moves, it follows the player, and he jumps insanely high and everything. So if we do this, we see, oh, it moves, but it's what we've done is we've just parented something to the player. So once again, to do that, you're going to, I'll detach it. You're going to click on main camera and click and drag it to player. And then it's going to parent it. It's going to make it a child of player, which means that anytime you move player, camera will move with it will move with it with respect to that. So as you can see, when I move player around the scene, the camera, which is this thing right here, moves with it. Now that's cool and all, but what if I don't know, what if I wanted to maybe, you know, sway a little or do something funny? Then we can't do that. So let's go ahead and detach it and make a camera follow script. So open up your scripts again, delete void start, and let's write a little funny script. So what do we want it to do? What do we want the camera to do? We want it to follow a target at a certain speed, right? So we have to type that. We're going to say public transform, because we want it to follow the transform of a game object, and we'll call it target. We'll also say public float speed to refer to how fast you want the camera to follow the target. So these are our two public variables that we have to set. But for now, we're going to write the rest of void update. So void update, we're going to say, okay, vector3, which is the camera target position, which I will say, I will type out. Generally, you're going to want to use kind of like a abbreviation, but we will say position. Incredible. Is equal to target dot position, just like that. So just to review, we're creating a vector3 called camera target position, and we're setting that equal to target dot position. So the dot position is its position in 3D space inside of the Unity editor. So next thing we're going to do is going to say camera target position dot z is equal to 10f. We're talking about z because that is the position of the camera in 3D space. Let me recheck. Can you show how to do background again? Of course. Okay. Background, yes. You're referring to seafoam green background. Okay, fine. I'll change it. So we go to main camera. If you click on main camera, you see it says camera, and then it says clear flags, background, culling, mask projection, etc., etc. It's really fun to play around with all these. It really changes the tone of your game drastically. If we have a FOV that's really close, right, you can see that we're going to have a really more of a sensual experience, really close to our player. Excuse me, as opposed to a perspective, more broad experience. If we go to orthographic view, you see that we begin to get the likings of a 2D game, right? We miss that angle of that we know and love, right? So we've changed the perspective. So I'm going to change it back to perspective view, and I'm going to keep my field of view at 60. Oh la la, oui oui. What is the F for again? Yes, so F refers to storing it as a float. That's kind of a more hardcore, like memory and computer engineering stuff. But it's just very important that anytime you store a float, you say F, or Unity will just get mad at you. It will say, what is this? I don't know what this is. So we put the F to note that it is a float value. So a float, I just go over that, is a floating point, which is a numeric type, which has 6 to 9 digits of precision. It takes up 4 bytes of memory. This is not important, but that's just why Unity doesn't like it, because a double takes 8 bytes, a decimal takes 16 bytes. So Unity likes to store things in 4-byte floats, which have enough range that you should never have to not use a float, generally. Okay. I missed it. We have to change to solid color. Yes, so I changed to a solid color. This is also where you would put a skybox in if you want like a nice night sky, or whatever the vibe is. If you change it to black, that's a bit ominous, right? That's how I got the spooky kind of game last time. I changed it to black and I got rid of our directional light. If you get rid of directional light, you get this silhouette experience. Actually, you get nothing because you can't see anything. But if we added the backlight, right, you get a silhouette experience. So let's go ahead and finish camera follow that I interrupted. So if we say camera target position dot z is equal to -10f, right? Make sure that's a negative. I should have mentioned that. So that it is in front of the player as opposed to behind them, right? Because I'll just show you really quickly. So with respect to the player, right, if you go ahead and look at this position, this X, Y, and Z position, right now we have it at -10. If we put it at +10, the camera would be behind the player facing the opposite direction, right? So we would see nothingness. But by putting it at -10, we see the player, and it's beautiful. It's just, well, I just like it a lot. I don't know. Anyways. So the last thing we have to do is we actually have to change the transform position of the camera with respect to the player, right? So let's say transform dot position is equal to vector3 dot lerp. Lerping is very exciting. Lerping refers to a linear interpolation between 2 points in 3D space. So we're going to do a vector3 lerp, and we're going to transform we're going to do that between transform dot position. As you can see here, lerping takes in a vector3 point, another vector3 point, and a float t. That float t is time. So we're going to say transform dot position, comma, that's our first point, camera target position, comma, speed times time dot delta time, a classic. So this is the position of our player, position of our camera, as denoted by our beautiful variable names, right? If I had named this, right, then you're suddenly like, what is that variable? That is disgusting, but we call it camera target position. At some point, you will start to name variables like, please help, and that will be fun, but will hurt you in the long run. So transform.position is equal to vector3 dot lerp, a linear interpolation, between transform position and camera position with respect to time. Speed dot time dot the time, like I said, refers to frame rate of Unity, saying it should take time to do these things. You shouldn't do them instantaneously. I want to see it, right? Because motion refers to right. This is 2 points. This is the interpolation, but it started at rest at 2 points, right? It arrived at rest at 2 points, but it interpolated between those 2 points. So that's what we're trying to replicate inside of Unity. So let's go back into Unity and let's go to our main camera. So in our main camera, which is where we change the background. Oh, look at that. This is very fun. Which is where we change the background colors. We're going to go ahead and add one more component. The component we're going to add is called camera follow, right? That's the script we just wrote, you and I together forever, right? And it has a speed and a target. So the target, we're going to click this little button right here. Actually, we'll do it the other way. You can click the little button, or you can literally take the player and drag it there, and it will say player transform. And speed, I have no idea. I have no idea what this is going to look like. So we're going to just wing it for now, and then let's go ahead and change some of these values. Let's change player speed to like 5. We'll change everything to 2. Let's change it to 5. Well, like this is just the fun part where you get to all play around with these variables. I think jump speed is perhaps too much. Change it to 1. There we go. And now you can see that we have a smooth sort of camera following system going on, as opposed to a child of the player, which would immediately follow the player, and it's a bit motion sickness inducing. So here we have a nice little player follow that, you know, is not as much smoother and nice. This player speed is very upsetting to me. Maybe we can turn down, if we put the speed to like 0.1, that's a bit too much, 0.5 maybe. There you go. Now we get this more of a fanciful dream-like experience. Beautiful. So now we're starting to really see a game. Okay. So that is our game. And this is something you can infinitely expand on, right? I want to add a power up. I want to add this. I want to add this. I want to add this. Blah blah blah. Until you get your final experience. So if we keep making little, you know, little platforms, we start to get the likes of a platforming game, right? So here we are, and we jump here. Let me make this not so disgusting. Here we go. Oh, he can barely make it. If maybe he got double jump, he can make it. That's something you could add, right? So he hits the wall. He can't go up there. He jumps all around. He's very happy. Just all around having a good time, I guess. No! Okay. I'm so sorry I had to see that. Anyways, let's add a light, just for fun. So if we right-click on a hierarchical view and we press light, we'll press point light, and the point light will spawn. We're going to reset the transform to 0, 0, 0. And let's go ahead and put the point light right in front of the player, just like that. We'll pretend he has a little flashlight, okay? Or a little lantern. He has a little lantern, okay? And then we're going to put the point light and we're going to drag it on top of player, so it's a child of player. So now wherever he goes, his little light follows him. Isn't that, I'm going to cry. His little light follows him, right? You see how his little light goes about. And if we make this range bigger, then you see, if we make the intensity more, we start to see a little, there it is, there it is. Look at that, look at that. There we go, okay. All right, and let's just, right, now we're getting something really, really exciting. So this is a little Unity game that you just made in under an hour or something like that. So congratulations. Now you slap a little main menu on there. You get a beginning and an end and multiple levels, something. You're really starting to look at something, but I'm very, very proud of you. I will check chat now. lerp. Yes, thank you, Jackson. Okay, cool. So like I said, aesthetically, you just start playing around with it. Now we have a scary sort of thing going on, right? Where he doesn't know where he's quite going. There we go. All right. That's my Unity live code thing, and only went a little wrong, right? That was pretty good. Okay. Well, I am now going to. Are there any Unity questions that I can answer while in editing? So I'm going to. I have a little bit more to talk about, but.
I have a question.
Yes.
I wanted to ask if there's anywhere we can find like a list of the most commonly used like functions in Unity, just so that we have, maybe something like that to ground us a little bit better.
For sure. I'm actually going to talk about resources now.
Awesome. Thanks.
No problem. Does anybody have any questions about Unity Editor or anything about the project we just created?
Yeah, I have a question about to expand upon this concept.
Sure.
So, following the player in a 2D perspective, is there any way we can create a curved path that the camera will follow the player around?
Yeah. So right now our camera only follows the player on the Z axis, right? Or excuse me, on a 2D axis. So are you referring to kind of I'm not exactly sure. You're talking about a curve in a 2D?
Yeah. We still follow the player from a 2D perspective, but they move in a 3D environment. Let's say if they're walking around a pillar, then we would
sure. So right now our player controller only accounts for moving left and right and up and down, right? But if you wanted to say use W and S, right, then you could do vertical movement that way, right? So that's how you would expand upon that using the player controller, and then you have to write code for the camera following script that also follows it, lerps motion in the Z direction as well. That's something that you can definitely do with online resources, or you can try it out yourself. But I like that. I like how you're thinking. It's very good. So I'll go ahead and wrap up my presentation. I will save this. Okay. All right, so here's my list of resources. Let's see. Okay, so yeah, my list of resources. This is how I learned Unity. Is you go on YouTube and you say, hey, how do I make this? It'll be kind of funny if I made a game like this. I like this mechanic. Let me try this. You go to Unity, you type in how to make blank in Unity, and then usually a Brachy's tutorial will pop up. We love this guy. He just quit, however, so that's very unfortunate. But these are my favorite, which I will link. I will link the slides in the chat in just a moment. But we love Unity Official. Unity is the best documented game engine in the entire world at the moment. So this is a really good resource. 3D Buzz, a really nice guy. Brachy's, my favorite. Pushy Pixels, and then random Russian guys and gals, right, all over. I've learned way more than just random people on the internet, just showing me something really simple. So also Unity Forums, Game Dev Stack Exchange. Almost everyone has had the problem you're having or has wanted to replicate some sort of mechanic that you also want to create. So that's a really good resource. It's just, like I said, when you get console errors inside of Unity, you can go ahead and copy them and paste them directly into Google, and hopefully it will give you a step-by-step tutorial on how to get rid of those. Game Dev Stack Exchange, like that, resources like Reddit, just like stuff like that is really good for comparing your code to other people's and just stuff like that. So my final recommendations for the game jam. If you have time, do a little mini game jam yourself, right? Think this would be funny if I made this mechanic from this game. I'd love to try that in Unity. Maybe you don't have a publishable end product, but it's a great way to familiarize yourself with the Unity engine. The hardest part of the game jam, of course, is the timer. So the more familiarized you're with the game engine, the faster you will do stuff. And yeah, The most important thing is, however, is that you always have a game that creates with limited bugs. So the first thing you want to make sure is that you create a game that is within scope, so that you're not like rushing at the very end. And determining scope is often the hardest thing that you have to do because you don't know, right? You don't know exactly what your team is capable of. So the best thing to do for that is underscope and then build features and mechanics on top of that. So use your amazing talent, but do something else too. That's something I really wanted to emphasize. Game jams are a really cool place to try things out, right? You can try things maybe you've never written a script before. Try that again. It's very easy to tell your vet or tell someone else, write the player controller script, but it might be fun for you to do that and have them focus on some other stuff. So yeah. And okay, so lastly, I'll get a lot of hate for this, but game jams are not about making your code look pretty. It's very important to make your projects readable so that others understand them and doing some comments, but don't worry about making it beautifully architected and stuff like that. Yeah, that was a bit too hard. So okay. So I showed you some basic project organization, which you try to follow as much as humanly possible. But it's pretty much inevitable for your project to fall apart at some point. It's kind of fun. So as you get closer to your end code etiquette becomes less and less. But yeah, try to comment your code as much as humanly possible. And yeah, thank you very much for your patience. If you have any questions, I'd be happy to answer them now or.
Yeah, I know that you guys are going to send out a recording for this, but is there a way for you to share like your code for this like little game that you've just made so I can compare it to my own, or at least like
Sure.
just the actual scripts?
Sure, I can definitely do that. Just the scripts, is that what you're talking about?
Yeah.
Cool. All right, I will go ahead and share my presentation right now, which doesn't have the code, but maybe I'm thinking of the best way to do that. Let me put this in the chat. I'll link it in the chat.
I think even just like a screenshot or a picture.
Oh, sure. Yeah, I can do that right now. I will screenshot it right now. I'm screenshotting camera follow.
Thank you.
No problem. Thank you very much.
Weston, if you'd like, you could also just save them as like .txt files, and then we can send them out tomorrow with the recording.
Cool. Yeah,
Yeah.
I can do that as well. I'll
Yeah.
send the I'll send screenshots now for those who want to do a code review. Incredible. Okay, so I've just put 2 JPEGs in the chat. Oh, access. Thank you. Sorry. Let me do that right now. Anyone with link? Anyone with? There you go. All right, now you can hopefully access it. Sorry. What application program will be using a multi-tool program? That's a very good question. You'll be using a version control software. I recommend using GitHub. GitHub is a wonderful, easy to use tool. I will link GitHub Desktop in the chat right now. That's a great question. It's desktop.github.com. You download this and then you make an account, and you can make people on your team a collaborator. This is much better than just uploading to a Google Drive and downloading. That's a really awful way to go about it. So try, if you can, use GitHub. Probably your vet has used it, or someone on your team has most likely used GitHub. So GitHub Desktop is you're just going to make a project on your computer, on your local hard drive, and then, or Perforce if you're used to your faculty writing in UDPs. And you're going to put a thing on your hard drive, or you're going to put the resources folder in your hard drive, and you can just push and pull from that. A word of advice: do not work on the same script at the same time as a teammate, because then it will not work. You'll have merge conflicts, and then you'll weep.
Don't work on the same file at
yeah.
the same time.
So
Don't work on the same scene.
Yeah. Don't work on the same scene. Don't work on the same script. Don't work on the same anything as another person, because it will be bad. Yes. Okay. Is there a reason Unity is collaboration? Oh, okay. You can also use Unity Collab. I have never done that. I have, but I have never set it up. In my understanding, it may be paid to some extent, but I'm not exactly certain. If I were you, I would just check it out. Unity Collab is pretty good. If you, yes. Okay. Yeah. Our small team. Okay, cool. Yeah. So Unity Collabs are really good. Is also a very good resource that's built inside of Unity. So definitely check that out if that's something you're into, I guess. I think max 3 people. Yeah. So if your team's more than 3 people, then you're probably going to want to use GitHub. All right. Is there anything else? If you're okay, cool. Yes, I recommend GitHub. GitHub Desktop.
I think you got a question from Alex.
Okay. No, Alex. Oh, and earlier, had to step out for a bit. But when you're not in play mode, can you change variables? Okay, great question. You can change variables while in play mode. However, it will, the second you get out of play mode, it will default back to the variables that it was before you stepped into play mode. So editing variables inside of play mode is very useful when you want to do stuff like, oh, well, how, you want to tweak jumping, right? So, all right, let's try 4, let's try 5, right? But the second you stop play mode, you stop the simulated session, right? The variables are going to default back to what they were before you began the play session.
What about if you're not in play mode?
Yes, so then you can change the variables.
I think his original question was about the difference between changing variables in Inspector and changing them in the script.
Right.
Got it. Yeah, sorry about that. Okay, so then for sure. Yeah, so when you declare them in a script, depending on where you declare them in the script, if you declare them outside of void start, then yeah, so if you declare them inside of void start, like you say speed equals 10 in void start, then anytime you start the play session, it will set it back to that. But if you declare them outside of them, I will show you here. You can see this. Yeah, you can still see my screen, right? So if you declare them here, you can change them very readily outside, right? But for example, if you have a start function, and inside void start you say like jump speed is equal to 10, right? So then anytime void start is called, it will set jump speed to 10, which is not what we want, because void start occurs at the moment you start playing the game. So yes, to answer your question, let's see, can you change variables in the inspector? Yes, you can change them in the inspector. Yes.
So then going back, I asked the question like way back an hour ago. So if you change the numbers in the inspector, that's not actually changing them in the script, right?
No, that's not changing them in the script. This is just default values. These are the default values that it defaults to.
If you drag the script onto an object, these are the values that you start at, but
yeah,
you can change it in the inspector. And once you've dragged it onto an object, changing it in the script can change it.
Yeah, I don't know if you heard that, but changing. So if you can drag these onto any script, or excuse me, any game object, and it will default to these values. But the moment you change them in inspector in those little fields, it will permanently stay those. Does that answer? Awesome, thank you. Okay. I will. Let's see. Okay. Is there anything else that I can answer? All right, this is my email. This is my website. This is my name. If you'd like anything, I will try to get back to you, help answer any questions I can. I really like long walks on the beach and stuff like that. So maybe we can work something out. That is my presentation. Thank you very much for coming, and good luck with your game jam if you so choose to participate. I look forward to playing some games, and yeah, thank you.
Thank you so much.
Thank you.
Thank you.